Hey YouTube, welcome back. Problem number 1351. Count negative numbers in assorted matrix. So in this problem, we are given an m multiplied by n matrix grid where elements are sorted in non-increasing order or descending order, both row-wise and column-wise, and our task is to count the total number of negative integers within this matrix. So we can take this as an example, and the expected output should be 8. The solution for this problem, we'll do it using a binary search. Like, since each row is sorted in non-increasing order for any given row, all the negative numbers will be grouped together at the right end of the row. This property makes each row a suitable candidate for binary search. How we will do that? Okay, we will do this in it. I guess it will be quite trickier at the beginning to understand it, but it's quite easy thing. Okay, so let's just create some variables. We will have like const, which will be m, which will be grid.length. This is for the columns, and the rows will be n equals grid of 0 dot length, and we will have the response number, or like total negatives that we need to return. Okay, but what should we do? So we will initialize a count to 0. It will be the total negative. This one, it's a count that we'll try to count all the negative numbers. We will make it to 0. Like, this variable will store the total number of negative numbers found across the entire matrix. And after that, we iterate for each row. Like, for each row in the grid, we need to find the first negative number in that row. And once we found the index of the first negative number, uh, we call it we can call it like first negative index or something like that. All elements from this index to the end of the row will be negative. If we found one negative number, since it's quite sorted, so if we find one negative number, that means all the elements to the end to the index are all of them are negatives. So using binary search, I guess it will make our life one more easier. So how it will work? Okay, so we have our three variables here. We will create a function. I will call it find first negative index. And when we just find the first negative index, that means all the numbers after it are negatives, or before it. So when you have a binary search solution, you need to know that we need three things. We need our left. We need two pointers, one for the left and one for the right. And the other one will be the mid. And we'll talk about how we will calculate the mid. Dot len -1. And first, I will create another one here, another variable, call it first negative index, and it will equals array.length. Basically, here we initialize to array.length, meaning to negative found yet. Okay, so we create a while loop, and we will say we create our while left is smaller than or equals right, and I will create mid. So let mid equals it will equals right plus left divided by 2, and we have add left to them as well, because we need to find the exact element of the mid that between left and right. So if left doesn't equal to 0, maybe left is 2 and right is 4. So 2 minus 4 divided by 2, it will be equals 1. But we will add the element of left to it, the value of left to it, to get the exact actual value of the element that between left and right. Okay, so it will equals math dot floor right minus left divided by 2, and I'll create the if statement here. If array of mid if array of mid actually less than 0, that means we found our negative number. So the first negative index will equals mid, and we basically here, and that means if this if statement is right, current element is negative, and it's a potential first negative. So we store its index and try to find any area 1 to its left. So it might be the first negative, but if we are not so sure yet, so we will just address right to equals mid minus 1, and else if basically array of mid is not smaller than 0, that means the current end element is non-negative. So first negative must be on its right. So we will move the left to be mid plus 1. Okay, it looks quite good. And I guess after that, in this while loop, after the end of this while loop, we will have found the um, the first negative, so we return it here. Okay, so after that we need, okay, so we created these helper functions to help us to find the first negative index. After that we will iterate through each row of the grid. So for let I equals 0 and I smaller than m and the I plus, okay, and I would say I'll create the row will equals grid of I, and I will call this functions. I'll create const first first negative index. First negative index will equals the values that comes here, and I will send here the array of the actual row. So I will get the first negative index of the row by this function, and when I get it, I will, like, if negative number was actually found in this row, then all elements from the first index to the end of the row are negative. So total negatives, this one here, will equal plus equals n minus first index, because we need to get all the numbers of all the left elements, and after that we will return here total elements. And let's run. It's not right. Why it's not right? Unexpected end of input. We return it. I guess it's right. Should be right. We return, and does we have anything wrong here? Let's submit and see what was the problem. Line 62. What? There is no 62 here. Syntax error, unexpected end of input. What was the wrong thing that I have done here? What was the wrong? Maybe let I equals 0 and I less than m. because for rows, I plus plus and a control. Yeah, there is something wrong, I guess. Yeah, because it should have some color in it, but like there's no color at all. So let's here let function let okay. I guess I need, okay, I'll just copy the function that I already created. Let me delete all the comments and see, maybe I actually have a problem in my actual solution and I don't know that, which is not good. Oh no, no, which is not good at all. Let's see. Okay, it did work. I guess I made something wrong, but I don't know what was it, to be honest. Okay, so let's describe this solution more. So we did use the binary search implementation. So actually, the most important thing is this functions, basically, in this function. The find first negative index. For for a given row, let's call it array, we initialize here left with 0 and right is equals array.length minus 1. And after that, we will use a variable called first negative index in row, or similar thing if you want to change it, to store the potential index of the first negative number we found, initializing it to array.length, which signifies that no negative numbers has been found yet, meaning all numbers are non-negative. We create a while loop while left is smaller than or equals right. We calculate mid, and after that we say if array of mid is less than 0. We found a negative number. This mid is potentially a candidate for the first negative number. Okay, we are here basically. If that was true, that means we found a negative number. So we record mid as the first negative index in a row. And to find if there is an even real or more to the left negative number, we continue searching in the left half. So right will equals mid minus 1. If that wasn't the case, that means the current element is non-negative. This means the first negative number, if it actually exists, must be in the right of mid. So we search in the right half by removing left to the right half. After the binary search loop completes, the first negative in a row and function will hold the index of the first negative number in the row. If no negative numbers were found, it will remain arrayed length. And we return the count, which is this number. So yeah, that's it, and this is how it works. I would say it's a quite easy problem. You just need to understand the trick of creating a helper functions to help you basically write more cleaner and readable code. So that's it for this video, and see you in the future.